Hello everyone and welcome to my improper integral video series. Now before we talk about improper integrals, let's first talk about the simple integral that I have given to you here. Now I am asking you to integrate e to the negative x, which is a very easy function to integrate, and I am asking you to integrate e to the negative x from x values 1 to 5, which make this integral a definite integral. That means when you evaluate this integral, you're gonna get a number. Now, can you remember what this number represents geometrically? Or what is the geometrical meaning of this definite integral? Can you remember that? Well, here's what it means. Here's the curve e to the negative x, graph of e to the negative x. What this integral means is that it is asking you to find the area under the curve e to the negative x from x values or trapped between the x values 1 and 5. Now that means it's asking you to find the area of the region that I highlight here. Now this totally makes sense, right? Because look at the region. The region is closed from everywhere, right? Bounded from everywhere. So if you have a region which is bounded from everywhere, you can definitely find the area, right? That's a practical thing. Great. Okay, so now let's do a small change to this integral. Now I'm going to integrate e to the negative x with respect to x. The lower boundary of the integral is going to be 1, pretty much the same thing, except instead of 5, I'm going to replace that 5 by infinity. Now what's the big deal with this integral? Let's try to think about this geometrically. Again, geometrically, the meaning of this definite integral is that you want to find the area under the curve e to the negative x for x values or trapped between the x values 1 and infinity. Now, the region that you're calculating the area, the boundary of the region, lower boundary of the region is extremely long, or it's not finite. Meaning, tell me what's the length of the lower boundary here. The length of the lower boundary, you cannot calculate it. It's not finite, it's infinity. So the interval that you are integrating over, it's infinitely long. Now at least this sounds not practical, right? Finding the area of a region where one boundary is not finite. It sounds not practical. Now think about this scenario. Think that you're going to your friend's place and think that your friend is asking you to find the area of his garden. Now if you want to find the area of the garden, first thing that you will look is you will look for the boundaries of the garden, right? You want to figure out where the fence is. So you will say, well, show me the fence. So you look at the fences and you figure out a boundary, and from there on you will calculate the area of a closed region, right? And that sounds practical to us. But here the region, one boundary, as I said, is infinitely long, which make this case unusual. So this integral is geometrically unusual, interesting, okay, or different from this regular interval. Because here in the first integral, the lower boundary, actually the length of the lower boundary, the distance between 1 and 5 is 4. That's finite. But here it's not the case. Now is it practical to find the area here? Well, let's talk about that in a later video. But for now, this case is interesting. And this type of an integral, we call it a type 1 improper integral. Now, is there a type 2 improper integral? Yes, there is. But for now, let's learn about type 1 improper integral. Okay, so let's look at another example. I'm going to write another integral. Let's take the same function e to the negative x, okay. Now let's say you want to integrate it between the x values negative infinity to negative 2, okay. Again, the interval that you are integrating over is again infinitely long, right? Now it's going from negative infinity to negative 2. Geometrically, now if you draw this, here's negative 2, okay, and your lower boundary is from negative infinity to negative 2. So this is this region. It seems to be like the lower boundary is not finite, okay. Again, this integral, because of that, an interesting integral, a different integral, okay. So this is another type 1 improper integral. Great. Let's do one more example. How about the integral where you have to integrate e to the negative x now from negative infinity to infinity. Now this is even worse, okay? Now you are asking me to find the area under the curve e to the negative x bounded by, okay, the entire x-axis. Now entire x-axis means, it's all the real numbers you can think of, right? So again, it sounds not practical, right? Again, this integral is very unusual. Okay, the interval that you're integrating over, of course, is infinitely long. Okay, again, this is a type 1 improper integral. Great. Now at this point, can you do me a favor? Can you try to explain to me what a type 1 improper integral in a nutshell? Can you explain it to yourself? How do you identify a type 1 improper integral? Well, it's very easy. If you're not blind, you can do this very easily. So if you want to know whether an integral is an improper in type 1 improper integral or not, just look at the bounds of the integral. So bound of the integral means the numbers that you put here and here, the numbers a and b in the integral. Okay, some people call them bounds, some people call them the limits of the integration. Okay, so if you see infinity or negative infinity or both in the bounds of the integral, that means your integral is a type 1 improper integral, because then you're going to integrate your function over an infinitely long interval. Okay, if there's no infinity or negative infinity, that's not possible. Okay, your interval is not infinitely long. So if you want your interval to be infinitely long, there has to be infinity or negative infinity or both explicitly present in the limits of or the bounds of the integral. Okay, then it's a type 1 improper integral. Okay, so now at this point we have to learn about type 2 improper integrals, which we will do in the next video. So hopefully I'll catch you up in the next video. Bye bye.